Hello everyone, welcome back. Let's talk about another medium problem on Leetcode today. Find unique binary string Leetcode 1980. If you are new to the channel, consider subscribing. I try to make daily videos on the problems related to data structures and algorithm, including detailed explanations, optimized solutions, and step-by-step walkthroughs to help you improve your coding skills. Now to the problem. In this problem, we are given an array of strings nums containing n unique binary strings, each of length n, and we should return the binary string of length n that does not appear in nums. If there are multiple answers, we may return any of them. Then in example 1, for the given nums array, we have two binary strings of length 2. So here we have n equal to 2. For length equal to 2, we can have binary strings like 0, 0, 0, 1, 1, 0, 1, 1. And we can see that 0, 1 and 1, 0 are already present in the nums array. But 0, 0 and 1, 1 are not. So we may return any of them. So we can return 1, 1 as our answer or 0, 0 as our answer. So both will work. Similarly, in example 2, the nums array contains the string 0, 0 and 0, 1. But we don't have 1, 0 or 1, 1. So we can either return 1, 1 or 1, 0. So any of them will be accepted as the answer. And finally, in example 3, we have three binary strings of length 3. And there are many binary strings like 0, 0, 0 or 0, 1, 0 and so on, which are not present in the nums array. So we can return any of them and that will be our answer. So in summary, the nums array will contain n unique binary strings of length n, and the solution guarantees that at least one missing binary string of length n always exists, as the total number of binary strings of length n is 2 to the power of n, while the nums array only has n strings and value of n lies between 1 and 16. Now in terms of solution, for the given n, we know that the binary numbers must fall within the range 0 to 2 to the power of n minus 1, or we can write it like 0 to 2 to the power of n, where 0 is inclusive but 2 to the power of n is not. Like for n equal to 2, it can fall in the range 0 to 3. Here 4 is not inclusive. So it will be from 0, 1, 2 and 3. Or if n is equal to 3, then it will be in the range 0 to 8. Again 8 not being inclusive. So we will be covering all the numbers from 0 to 7. And in this problem, we are given n binary strings. And we have to return any binary string in this range 0 to 2 to the power of n minus 1, which don't exist in this nums array. So one approach can be that we convert these binary strings to integers, because then we can easily compare the numbers in the range 0 to 2 to the power of n. So we can loop on the numbers from 0 to 2 to the power of n minus 1 and check if the number is missing from the nums array. And how can we do that? We can add the converted binary numbers to the hash set, as adding the elements and looking them up in the hash set takes O of 1 time. So we can create a set and add the numbers to it. So first we add 0, as 0, 0 becomes 0 and 0, 1 becomes 1. So we add the numbers 0 and 1 to the set. And now we can loop through the numbers from 0 to 2 to the power of n minus 1 and see first missing binary number and return it back. So first number we see is 0, it is in the set. So we continue. Then we see 1, 1 is also in the set. So we continue. Then we see 2 and 2 is not in the set. So that means this is the first number which is not present in the nums array. So we convert it back to binary string. So 2 becomes 1, 0 and that will be our output, because we can return any string which is missing from the nums array. Now in terms of time complexity, converting a single binary string of length n takes O of n time, and we are converting n binary strings in the nums array. So because of this, the time complexity will be O of n square. And then we are adding the elements to the hash set that takes O of n time. So overall the time complexity of this step was O of n square. And then we are looping on the integers from 0 to 2 to the power of n minus 1. And this may give the impression that our time complexity here is O of 2 to the power of n. But actually it is O of n, because in the worst case, we need to perform the check for only n plus 1 iterations, as our loop will terminate as soon as we find an integer which is missing from the set, and each lookup time in hash set takes O of 1 time. So because of this, the time complexity of this loop is O of n. And in terms of space complexity, it will be O of n for storing n integers in the hash set. Now let's cover some important implementation details in Java regarding this approach. In Java, we can easily convert a binary string into an integer using the built-in method integer.parseInt. The first argument of this function is binary string, and the second argument is the base or radix of the number system. For binary number system it is 2, and for decimal number system it will be 10, and so on. So here we will pass in the value 2 for it. And once we have converted it to integer, we add it to the hash set, and then later on when we find a number which does not exist in this hash set, we get that number as an integer from the hash set. So for example, we got the number as 2, and then we convert it to the binary string, and this is where we can use the method integer to binary string, which converts this number to binary string like 10. But suppose n was equal to 3, then our output should be 010 and not 10, right? So to fix it, we will use string.format method, where in first argument we pass in the format, and in second argument we pass in the input binary string which has to be formatted. In the format, this $sign is a format specifier telling Java that we want to format a value in a particular way, and the and indicates the minimum length or width of the resulting string. For example, here it is 3, and S stands for string, telling Java that we are formatting the string and not number or decimal or some other data type. So we will get the string of length 3 with a space and then 10, but we want the output like 010, so we will replace the space with 0, and our output now becomes 010 that we can return. So these were some important implementation details when writing this code in Java. Similarly, if we are writing this code in Python, we can convert the binary string to integer using the int function, passing the binary string as first argument and the base of the number system as second argument. And then when we are converting the first missing number from integer to binary string, we can use the format function, where we pass in the integer as the first argument and format as second argument. So here we are specifying with n, get me the string with length n. For example, if number is equal to 2 and n is equal to 3, here we are telling the format function that get me the string of length 3, and b specifies that number should be a binary number, so it converts 2 to 10, and this 0 tells that fill in rest of the string with zeros, so that's why we will get our output as 010. Now this approach is simple and efficient, but what if the interviewer explicitly asks us to avoid these inbuilt methods? Then we have to implement these methods on our own, and this may take a lot of time. So in such a scenario, we can use a simpler and intuitive approach, and that is backtracking. Here we start with an empty string and systematically explore all possible binary strings of length n through backtracking. So at each step, we either append 0 or 1 to the current string, and once we have generated the string of length n, we check whether it's absent from the nums array. And for efficient lookups, again we can use a hash set as we did in the previous approach. A hash set allows us for O1 lookup times. So for example, for this nums array, we will add the string 00 and 01 to the hash set, and in this example n is equal to 2. So as soon as we have formed the string of length 2, we will immediately check if it exists in the hash set. If it does, then we will continue, but if it doesn't, then we will return it as an answer immediately. So for example, first we saw 0, then again we go to the left, we saw 0, and now we have created the string of length 2, that is 00, and that is present in the hash set. So this branch does not succeed, hence we backtrack, and this time we append 1 and form the string 01, and it is also present in the hash set. So this branch also does not succeed, hence we backtrack and append 1 to the result. Now our current string becomes 1, and we again add 0 to it and get the string 10, which is not present in the hash set. So this is the first missing string. So we stop our backtracking and return 10 as our answer. Here is a more elegant depiction of recursion tree that we just went through. And here is the code with Java code on left and Python on right. First we are creating a set and add all the strings from the nums array to this set and call the backtrack method. And in the backtrack method, our base case is when the length of the current string is equal to n. In that case, we check if the string is already present in the num set. If it is, then we will return an empty string and terminate the recursion. Otherwise, we will return the current string as our answer. And if the string has not reached our desired length, then we append 0 to it and explore going down that recursive path and check if we found the valid answer. If we did, then we will return it. Otherwise, we will append 1 to it and again go down the recursive path in search for the answer. And now in terms of time complexity, it will be O of n square, because first we add numbers from nums array to the hash set that takes O of n time. And then we try to find first missing binary string using backtracking. If we would have generated all the strings in the worst case, then the time complexity would have been O of 2 to the power of n. But here, in the worst case, we will be exploring n plus 1 strings and stopping the algorithm as soon as we find the answer. So at most, we will perform O of n iterations, and in each recursive call, we are performing string concatenation operation, where we are appending 0 or 1. And in programming languages like Java and Python, where strings are immutable, string concatenation is an O of n operation, because each time we are creating a new string which takes O of n time. So overall time complexity in those languages will be O of n square. And in terms of space complexity also, it will be O of n square, because we are storing n strings of length n in the hash set, resulting in space complexity of O of n square. And then the algorithm takes O of n space due to the recursion stack. Now let's look at the last approach that we want to cover, which uses Cantor's diagonal argument, a mathematical concept that guarantees constructing a string that is unique, not present in the given list. Let's look at how this works step by step with input nums array having strings 111, 011 and 010. The idea is to construct a binary string, that is our answer, that differs from every string in the nums array in exactly one position, that is diagonal index. So we will pick up the ith string in the array nums and flip the ith index and append or update the flipped character at the ith position in the final answer string. And once we are done with all the strings, we will return our answer. So let's see this in action. First, let's take 0th string 111 and take the 0th character in it and flip it. Now 1 becomes 0 and we set it in the answer string at 0th index. Now at this point, the answer string differs from the 0th string at position 0. So it is definitely not same as the first string. Now let's take first string, which is 011, and flip the first position in it. That is, the character 1 becomes 0 and update it in the answer string at first index. So now our answer string becomes 00. Now note that even though this character and this character is same between this string and our answer string, it still differs from string 1 at index 1, right? So it will be definitely different from both the strings we have seen so far. And now we look at the final string, where we take the last character, that is the character at index 2, that is 0, and flip it and make 1 out of it and set it index 2 in answer string. And now our answer string becomes 001, which differs from each of the string in the nums array, resulting in a different string of length n, which is missing from the nums array. So that's why that will be our answer. Here is a quick code walkthrough of the same. We create answer array of size n and loop through the strings in the nums array. And for each ith string, we get the ith character and flip it and set it at the ith index in the answer, and in the end return our answer. And now in terms of time complexity, it will be O of n, because we are going through each string only once, taking its ith character that takes O of 1 time, and then we flip that character and set it at the ith index in the answer that again takes O of 1 time. So because of this, the overall time complexity is O of n. And in terms of space complexity, the auxiliary space complexity is O of 1, but if we consider the space required for the answer, then it will be O of n. And out of all the approaches we have covered, I prefer the second one, where we use backtracking, because it is the easiest to implement in the interview setting. The first approach, where we did the number conversion, relies heavily on the inbuilt methods, whereas the last approach, while elegant, can be like a show-off. But it's up to you, whichever approach you prefer. So that's all for this video. I hope this video was useful to you. If it was, please give it a thumbs up and share it with others who might benefit from it. If you haven't subscribed the channel yet, make sure to hit the subscribe button and turn on the notification bell so that you never miss an update. Your support helps me create more content like this. If you have any questions or suggestions, feel free to leave them in the comments below. Thanks for watching and see you in the next one.